China's recent silence regarding the interstellar object 3I Atlas has raised questions that extend far beyond astronomy. Days after the object's close passage by Mars, data that should have flooded the world's scientific networks never arrived. No images were released from any of the 5 orbiters in position to observe it. The most conspicuous absence came from China's Tianwen-1 mission, whose cameras have delivered more than 14,000 Mars images since 2021, until now. Just as the silence deepened, a new rocket rose from the sea off Shandong, Gravity-1 Y2. The proximity of events has drawn attention from scientists and strategists alike. China's refusal to release imagery suggests that something unexpected was detected during the flyby, something requiring further verification or, more provocatively, action. The Gravity-1 Y2 mission, though publicly described as a satellite deployment, may have carried a payload designed to observe or even intercept the interstellar visitor. The claim is unconfirmed, but the circumstances, timing, secrecy, and the broader political context of strategic space competition give the theory unusual weight. In a climate where national space programs serve as instruments of both science and statecraft, it is not difficult to imagine that an unexplained object moving through the inner solar system might prompt a rapid, discrete response. Gravity-1 Y2 is, by every official metric, a technological milestone. The launch took place at 10:20 a.m. Beijing time on October 11, 2025, from an offshore platform near Haiyang, eastern China. The Taiwan Satellite Launch Center managed the mission. According to public statements, the rocket carried 3 satellites, 1 wide-field observational unit, and 2 experimental payloads, and successfully placed them into their designated orbits. The vehicle executed an unusual 40-degree yaw maneuver shortly after ignition, redirecting its trajectory from southeast to due south within seconds. Engineers describe this as a demonstration of control precision and flexibility for maritime launches. The rocket specifications are impressive and fully documented. Developed by the private aerospace firm Orion Space, Gravity-1 is a solid-fuel launch vehicle with a low Earth orbit payload capacity of 6.5 tons and the ability to deliver 4.2 tons to a 500-kilometer sun-synchronous orbit. Its design includes a solid propellant core stage supported by 4 strap-on boosters, providing a combined liftoff thrust exceeding 600 tons. The vehicle can deploy more than 10 small satellites in a single mission, and its sea launch capability allows it to operate outside fixed-ground infrastructure, offering strategic mobility. The Y2 model followed the successful maiden flight of Y1 in January 2024, which set records as the world's most powerful solid-fuel rocket and the largest commercial launcher built by a private Chinese enterprise. These details are verifiable, reported by state media and aerospace outlets, yet beyond them lies a persistent opacity typical of China's strategic projects. The nature of the experimental satellites was not disclosed. No images of the payload fairing or orbital deployment were released. China's space program has a history of partial transparency, celebrating achievements, concealing capabilities. The country's military-civil fusion model ensures that technological progress serves dual purposes. While the official record identifies a commercial launch, the possibility remains that additional hardware, unlisted in public manifests, shared the rocket's trajectory. To understand why such secrecy attracts attention, one must examine the target of speculation itself. 3I Atlas is the 3rd confirmed interstellar object to visit the solar system, following Oumuamua in 2017 and 2I Borisov in 2019. It was discovered on July 1, 2025 by the Asteroid Terrestrial Impact Last Alert System, ATLAS, telescope in Chile. Its orbit is hyperbolic, proving that it originated beyond the Sun's gravitational influence. NASA's Planetary Defense Coordination Office lists its closest approach to the Sun, perihelion, on October 30, 2025, at a distance of about 1.4 astronomical units, or roughly 207 million kilometers. The object passed Mars earlier that month at about 90 million kilometers, a rare alignment that allowed multiple orbiters to observe it simultaneously. Measurements from the Hubble Space Telescope suggest a nucleus no larger than 5 or 6 kilometers, though it may be considerably smaller. Spectral studies indicate significant outgassing even far from the Sun, implying volatile materials more active than those found in typical comets. Observations from NASA's James Webb Space Telescope in August 2025 detected water-related emissions at distances where such sublimation should be minimal, with production rates estimated around 40 kilograms per second. Polarimetric data reveal unusual surface scattering, anomalously strong negative polarization, suggesting dust or structural properties not seen in other comets. Compositionally, 3I Atlas displays a carbon dioxide to water ratio around 8:1, a value that challenges current models of comet formation. Reports also mention excess nickel compared with iron and an absence of the diatomic carbon signatures that define most comets. Even its orbital path is peculiar. After entering the inner solar system, it executed a chain of near-planetary encounters, Venus, Mars, and Jupiter, in a sequence that computer models suggest has less than a 1 in 20,000 probability of purely natural. Its estimated age, based on trajectory modeling and exposure history, lies between 7 and 14 billion years, predating the formation of the Sun. To planetary scientists, it is already an anomaly. To others, a potential artifact. Among those exploring the latter idea is astrophysicist Avi Loeb of Harvard University. Loeb proposed two possibilities. Either the object will fragment naturally as solar heat vaporizes volatile ices, or it may release smaller bodies in a controlled pattern, akin to probes dispatched by larger craft. The second scenario, while speculative, stems from precedent. Loeb earlier argued that Oumuamua's acceleration could have been non-gravitational, possibly the result of light sail propulsion. In the case of 3I Atlas, he notes that despite active outgassing, no measurable non-gravitational acceleration has been observed, a contradiction difficult to reconcile with standard comet physics. Loeb's framing has captured the public imagination. If the object were to disintegrate in a structured or synchronized way, releasing smaller units or emitting coherent signals, it would force a redefinition of what constitutes natural. He emphasizes that confirmation or refutation depends on data from spacecraft near Mars, the very data that remain unreleased. In that context, the absence of imagery becomes evidence of its own kind, a silence suggesting not indifference, but deliberation. The possibility that China, possessing direct visual data from Tianwen-1, chose not to release it has fueled the link between Loeb's speculation and the Gravity-1 Y2 launch. If the images showed geometric features or motion inconsistent with rotation, the information would immediately shift from scientific to strategic. A rapid sea-based launch capable of deploying experimental payloads might then represent an attempt either to gather more information or to mitigate a perceived risk. Gravity-1's configuration allows for small, high-velocity probes, communication relays, or kinetic test units. Even a limited intercept test within Earth orbit would constitute a proof of concept for planetary defense operations, a capability Beijing has openly discussed since the 2021 debris mitigation exercises. Official statements, however, remain ordinary. Chinese media reported only that the mission demonstrated improved stability under oceanic conditions and validated systems for future constellations of remote sensing satellites. No reference was made to 3I Atlas or to any deep space trajectory. Yet the coincidence of timing continues to attract scrutiny. The launch occurred less than 2 weeks after the interstellar object's Mars passage, the same window during which every major agency fell silent. International observers recall that during previous anomalies, such as Oumuamua's unexpected acceleration, data emerged within days. In contrast, the present blackout has lasted longer, involving multiple independent missions across rival nations. The uniformity of silence suggests coordination or shared concern. Some have pointed to existing SETI post-detection protocols, which recommend consultation among space agencies and verification before public release. If all 5 orbiters recorded something inexplicable, an embargo could be consistent with those guidelines. Still, the unique behavior of China's program complicates this interpretation. Historically, it has seized on Western hesitation to showcase its own transparency and technical prowess. That it has refrained from doing so now implies that the data may contain elements too controversial for unilateral publication. If so, Gravity-1 Y2's launch could represent a unilateral contingency, China moving while others deliberate. There are alternate explanations. The Y2 launch might simply reflect the rapid cadence of Arianespace's commercial schedule. The blackout could be bureaucratic inertia, calibration delay, or image quality issues. Yet even these benign reasons leave the temporal overlap unresolved. In science, coincidences can occur. In geopolitics, they rarely do. For the scientific community, 3I Atlas remains a puzzle demanding empirical answers. Its composition and trajectory expand the catalog of interstellar materials. Its anomalies invite revisions to formation theories. For policymakers, however, the object symbolizes a different frontier, the point at which scientific discovery and planetary defense intersect. If any component of 3I Atlas behaves in a way that challenges natural explanation, the issue shifts from astronomy to security. In that context, a powerful mobile launcher capable of rapid deployment at sea assumes new significance. Until verified evidence emerges, the world remains suspended between two interpretations, one of routine spaceflight and natural phenomena, another of cautious response to an interstellar mystery. The distinction may determine whether the story of 3I Atlas is remembered as an astronomical curiosity or as the quiet beginning of contact. For now, the object continues its journey outward, past Mars and into the dark beyond Jupiter's orbit. The orbiters that observed it have gone silent. The agencies that control them have not spoken. And on Earth, a single line in a launch manifest, experimental satellite, remains the only clue linking a rocket that rose from the sea to a traveler from another star.